All right, welcome back to another stats video. This one is on finding the percentile rank of a value in a distribution. Let's see what that's all about. So percentile helps us to understand how a score or a value ranks versus the other ones in a distribution. When we try to understand the percentile, the name itself is a big hint. Now, percentile is a ranking that tells us what percent of the values in a distribution scored equal to or below the one that we're being asked about in the question. Now, before we see any examples, it's important to remember a couple of key points. First, the values in your distribution have to be written in ascending order. That means from least to greatest. Second, the best possible percentile you can be in is the 100th. Every other score will fall somewhere below that. Third, all values in a distribution that have tied with the same score will all receive identical percentiles. You can't say that one of those same scores performed any better than another. Fourth, when calculating percentile using the formula, if your answer has a decimal in it, even if that decimal is really small, like 0.1 or 0.01, we always round up to the next integer. So anything you get with a decimal in it, you round it up to the next number. And this obviously goes against everything that we've learned until now about rounding numbers. But we're going to follow that rounding up rule whenever we use this formula. Now let's take a look at this formula. As you can see, it's a little bit wordy, but I wanted to make sure that at first glance you understood what I was talking about and where the numbers are coming from. So what I'm going to do here is look at all the values in my list, which are already in ascending order, and count all the ones that are lower than the one I'm being asked about in the question. Once I find out how many scores are lower than the one I'm being asked about, that's the first number I put in my formula right here. Next, I have to count how many values are tied with the one I'm measuring, and I always count the value itself. So notice how in this question there are 3 of the values I'm being asked about. I'm going to take 3 and put it in the brackets right here where it says number of scores equal to the one in question. If there was only one score in the distribution with the value that I was looking for, I would have a 1 in my brackets instead of a 3. So once I calculate and add up the numbers on top of the fraction, I'm going to divide by the number of values in my distribution and multiply by 100. I got a decimal here in my answer, and remember, in this formula, any decimal answer gets rounded up to the next integer. So I'm going to go ahead and do that and get my final answer. Let's see a couple of examples of the formula we just learned.
Hey, welcome to Percentile. We're looking here at the instructional video for question number 1, percentile. Rank. The following list represents the heights in centimeters of students in a class in increasing order. So the shortest kid in the class is coming in at 138 centimeters, whereas the tallest kid in this particular class is measuring in at 152 centimeters. And we want to know what is the percentile rank of a student with a height of 147 centimeters. So a couple of key things to note here before I get into the formula. Obviously, things to look for to tell you what you're doing when we ask you for percentile rank straight up. There's a formula that we're going to use, so watch for those keywords. And of course, this is a significant number here because that right there is our target number. This is the one that we're being asked about. So the one that we're shooting for, or the target. So before we begin trying to figure out what that is, I want to remind you what a percentile is. What it really breaks down to is what percentage of the data points would somebody who is 147 centimeters tall be either greater than or equal to. So if you're this kid right here, we're asking you what percentage of the class are you taller than or the same as. It's kind of ranking yourself out of 100. And so the formula for that is really easy. The percentile, in order to calculate it, is really just based on knowing 3 numbers. The percentile will be equal to always the same thing. It's going to be the number of values less than the target number. So the number of values less than that target. And then to that, we're going to add 1/2 the number of values equal to the target. So the number of values equal to the target divided by 2. We're going to simplify that number. And then we're going to take, sorry for the smudge there, and then we're going to take the whole thing and we're going to divide that by the total number of values in the data distribution. And at the end, we will times it by 100. And this is key. We will always, always, always round up, regardless of how small the decimal is. And we'll see that in some other examples. So we're going to go ahead and calculate the percentile rank of somebody with a 147. So in order to do that, there's a couple of tricks that I use. First thing I do is I go and find the 147. There it is. And I'll just take note, we only have one of them. And so we know that there's going to be a 1 over here. We also need to know the number of values that are less than that target. So less than the 147, that's going to be made up of, since these are already in order, all of these ones over here. So if we count them out, we're going to see that there are 9 of those. And the last thing that we need to remember for the bottom part of the fraction over here is how many there are in total. And it turns out that there are a total here of 14. So once you know those three numbers, the number equal to the target that we're being asked about, the numbers less than that we're being asked about, and then the total number, we're going to put those three numbers into the formula and simplify it. So this is what that would look like. Our percentile for this particular question will be equal to 9, so the number of values less, plus the number of values equal to the target. I only have one, 147. The kid herself or the kid himself, 1, which I have to put over 2 afterwards, and we know we're going to change that into a decimal. And then I'm going to divide that whole thing by the total number of values, which I've already figured out is 14. And at the end, I'll times it by 100. But we're going to simplify this first here, and we'll get 9 plus 1 divided by 2 is 0.5, which I'm going to have to divide by 14. And that's going to be equal to 9.5 divided by 14, which I'll times by 100. So we'll do that on the calculator right now and go 9.5 divided by 14. Hit equals. Always, always, always hit that equals button. And then times it by 100 and hit equals again. And in this case, you're going to get 67.85. But regardless of what the decimal is, I'm always going to round it up to the next biggest number. So in this case, this kid would be in the 68th percentile. So if you're a kid who's 147 centimeters tall, you are taller than or equal to 68% of the kids in your class. Hey guys, this is percentile rank question number 2. The data below shows a salary of 220 employees in a company in increasing order. So the lowest guy on the totem pole is making $22,000 a year. Highest guy's making $78,000 a year. And we want to know, what is the percentile rank? There's the keyword right there, of an employee with a salary of $36,500. So if you're one of these three dudes here making $36,500, we're really kind of saying, hey, what percentage of the employees in the company do you make more than or the same as? So percentile rank, straight up formula, really easy as you'll remember to manipulate, is equal to the number of values less than the target plus the number of values equal to the target divided by 2, and then we're going to take that whole thing and we're going to divide it by the total number of values, and we'll multiply that by 100, and then at the very end, always, always, always round up. And it's going to be interesting in this particular example when we see that. So we're going to just move straight over to calculation land over here, and we'll say, hey, our percentile rank, or our PR, is equal to. So the number of values less than 36,500. So here's our 36,500s right over here. And we can see there's 3 of those. But the numbers less are all these guys over here. So they've kind of grouped them and counted them for us. They've done the work, right? So 153, really easy number to see. So that's this part of the formula. Now we're going to add the number of values equal to the 36,500 and divide that by 2. So there are 3 in this case. Last time we only had 1, but so we're going to add 3 over 2. So I know that's ugly, a little fraction there. We'll take care of that after. We're going to divide the whole thing by the total number. They told us the total number of employees in the company is 220. If you didn't know that, you could have added 153 plus 64 plus those 3, and those 3 groups of numbers will come to 220. And so all we have to do now is kind of simplify this and round it off. Sorry about that, didn't have my calculator in the shot there. So I'm going to change that into a decimal. So 153 plus, we've got to go 3 divided by 2, which is going to give us 1.5. So 1.5. And then we're going to divide that by 220, which at the end will multiply. But first, let's simplify that on the top. Clear that up. 153 plus 1.5 is going to be equal to 154.5. And then we have to divide that by 220. 154.5 divided by 220 is going to be equal to that. Now, remember, at the end, we have to multiply it by 100. Hit that equals. And now we get this number over here, 70.22 something or other. And I know that the temptation for a lot of you, the way you've been taught and properly to round, is to say, okay, well, 70.2, we're going to round that off to 70 if we're keeping just the whole number. But in percentile, we are going to take any single decimal, and we are always going to round up. So that 70.22 is going to get rounded up to the next whole number here. So the answer in this case is the 71st percentile. Okay, so don't get fooled, right? Always make sure you round that decimal up when we're doing percentile. Of course, that'll be different when we're doing percentile backwards, but we'll get there.